In this next example, we are given the decibel level, 50 decibels for part A, 81 decibels for part B, and I want to convert that into a sound intensity. This is slightly harder, it's a little trickier. So you're given the value of beta. You're looking for the value of I in the numerator here. That's why I put these up here. You're given this, and we're going to be able to express it in terms of a logarithm. But we need to take that, we'll write that out first and then convert that into exponent form. Okay? It's very helpful if you can remember this. Right? In exponent form, y equals b to the power x. If you take that equation and write it in logarithmic form, the b is here, the base of the logarithm. There's your y value, which in this case is what's in parentheses here. And here's your x value, okay, which is whatever your beta is. Actually, beta divided by 10, because I'm going to have to divide 10 over here just to get log by itself. Okay. To do part A, let's write this out. 50, that's beta, equals 10, that 10 right there, log to the base 10 of the stuff in parentheses, which is I or I sub 0. I sub 0 is going to be 10 to the negative 12. First thing you need to do is divide this 10 over here, okay? Because this equation doesn't have a 10 in front of it. So 5 over 10 is 5. 50 over 10, excuse me, is 5. That becomes log to the base 10 of I over I sub 0. Now you just have to look at this, look at that, look at that. Okay, what's your y value? It's whatever's here, all right? So everything in parentheses, that's y. I'm going to write that to the left of the equal sign. So I over I sub 0. That's the stuff that was in parentheses here, represents y. So I'm going to put it right there. Well, what's my base? My base is 10. That's b. And then what's my x value? X is 5. So, okay. I have to solve for I. So I equals, let's multiply both sides by I sub 0. It's going to be I sub 0 times 10 to the 5. Remember that I sub 0 is 10 to the negative 12 for all the problems that we're doing. So 10 to the negative 12 times 10 to the 5. We have the same bases. So you can add your exponents. Negative 12 plus 5 is negative 7, right? So the intensity of this wave is 10 to the negative 7 watts per meter squared. Okay. Now let's just continue on. I'm going to erase this and do part B. Just a tiny bit harder, because there's one extra step. Part B. Write out the equation. Beta is 81. So 81 equals 10, that 10 right there, log to the base 10 of the stuff in parentheses, I over I sub 0. Divide through by 10. Because again, we don't have a 10 in front of this log, so we have to get that to the other side. 81 over 10 is 8.1 equals log to the base 10. And we always, with logarithms or with decibel levels, we're always dealing with log to the base 10. It'll always be base 10. Of the stuff in parentheses here, I over I sub 0. Oopsies. I sometimes say I not being the same thing as 0, N-A-U-G-H-T, that kind of not. All right, so this is your y value. Again, I'm doing the conversion. Whatever's over here with this stuff right there equals your base, which is 10, and then to the power of whatever's here, which is 8.1. Excuse me. I over I sub 0 equals 10 to the power 8.1. Multiply that to the other side. Remember, that's 10 to the negative 12. Multiply that to the other side, 10 to the negative 12. That. Same thing. Times 10 to the 8.1. That becomes, or you add exponents, negative 12 plus 8.1 is 3.9. Don't leave it like that. Instead, use your calculator. You can use second function logarithm is 10 to the x. And so just hit that and type in 3.9, or you can use that the 10 and then that little hat thing, 3.9. Either one will give you this. It's oh, by the way, there's a negative sign in front of that. Oops. Where is it? Where did I get the answer to that? It's 1.26 times 10 to the negative 4 is what it looks like. Watts per meter squared. Let me just double check that. I can't read my writing. So, negative 3.9. Yeah, 1.26 times 10 to the negative 4 watts per meter squared. That's the answer.